Let's discuss exercise 8C. And before that, I would like to discuss one thing, the example 4. We missed this one, and it's a good one. This is a plane, and oh, there are few forces, four forces. This is E, and this is B, and this is C, and this is D. So A is called upward thrust. Now this upward thrust is stop fall in the aeroplane. B is forward thrust created by the engine. Absorb the wind and push. Absorb the wind, push. As a result, this is going moving forward. C is the weight, and D is the air resistance. Usually we put this direction, but actually it is acting on each and every space, surface, everywhere to every part of the plane, but simply we accumulate that for all the forces and right as a one force instead of all. So this is going to be D, air resistance. Air resistance is clear, weight is clear, forward thrust due to engine, upward thrust. So usually if you follow the Bernoulli theorem, you will see that how the theory behind it, that how the plane create the upward thrust. If I try to give a light idea, assume that two people come to alpha and beta to front of the people front, and they want to meet at the end as well. Now you can see that, so this is the requirement. He has to go very long journey, sorry, short journey. This beta times is short the journey, and alpha has to go a long journey because the shape is like this. Now, beta and alpha have the same time. Then, what is the task of alpha? So, alpha have to run fast because the same time they have, but alpha has to come a long distance because of the alpha has to run fast. So, as a result, in this area, so what will happen? There are two layers of wind come like this and alpha beta. The one layer going like this from the bottom, the other layer going from the up, and as a result, this upper layer to has to go fast, should go fast to reach to match with the same place. As a result of moving fast in this area, it will make a low pressure area. So this area is high pressure area. This because of that, it automatically we know that pressure is more. Anything move from low to high to low. Voltage is go to high to low. Wind is go to high to low. So likewise, uh, that will it will create a situation that this air should go high to low. As a result, it create a thrust on the plane. So now uh, we have to convert this one into the 65 km kilometer per hour. We have to turn this one into meter uh, per second or meter over s. this is power 1, it will come on the top as a negative power. 65 kilometer to meter, so we have to multiply by 1000, and I will rewrite this area 65 over 1 kilometer and h like this. I'll bring h down, so 65 over 1. So 65 times 1000, then this is 1 hour. So 1 hour we have to turn into a minutes multiplying by 60, and then minutes we have to turn into a second. So then this is going to be meter per second. Kilometer turn into a meter, and this 1 hour turning into a seconds. In simple, we know that to make 1 hour into a second, we have to multiply by 3600. 60 times 6, that is the value. So this is basically 65 3600 m over s, or ms minus 1. So you will get answer as 18.1 ms minus 1 meter per second. Part B is 15 gram per square centimeter. So 15 g cm square. So 15 g cm times cm square. So 15 over 1. Now this gram I need to make into kilogram. So I have to divide it by 1000. So 15 divided by 1000. Then it has become kilogram. And now here 1 I need to divide by, I'll make it a bit clear, 15. So this is 1 cm times 1 cm. So we divide 15 by, so this 1 cm I want to make into a meter. So I have to divide by 100. And this one I need to divide again by 100. So this is become then meter times meter. So 15 divided by 1000, this is the big division, and 1 divided by 100 times 1 over 100. So this is going to be 15 over 1000, 1 over 10,000. Then you will know that 15 over 1000 multiplied by 1 over, 10,000, this is 10,000. So this is cancel out, and this 150 kg in here. So 15 divided by 1000, this part how I did 15 over 1000 over 1 over 10,000. This is going to be 15,000. Part C, 30 centimeter per minute. So this is going to be 30 cm divided by 1 minute. So centimeter you can make to a meter by dividing 100. So this has become meter, and 1 minute, when you multiply by 60 seconds, you will get the seconds. So this is 30 divided by 100, and the major division by 60. Now how do you do this one? Just put one more one. Then 30, 100 divided by 60 over 1. Then this is going to be 30 over 100. Or you can leave this one here, right? So 30 over 100 divided by 60. And now you can put 1, and 30 over 100 multiplied by 1 over 60. Oh, this is cancel out. This is going to be 2. So this is going to be 1 over 200, or 5 10 to the power minus 3. M is minus 1. 1 divided by 200. Right? There is no keep decimal. Take one more. See 0, and take one more 0. It doesn't goes, then 1000 is goes fine. 0.005 is 5, 1, 2, 3, 10 to the power minus 3. So we need everything in kilogram, meter, and seconds. So now the part D, 24 G per cubic meter. So I can see that there is no problem. This is in meters. The only issue with this one is the gram. So I need to make this gram into a kilogram. So at present it is in this form, 24 G, and 1 meter times 1 meter. Sorry, 1 meter, and 24 I need to make into a kilogram. So 25 divided by 1000, then it is become kg, and now I will leave as it is everything. So this is going to be 24 divided by 1000, 0.024. You want to bring 3, so this is going to be 2.4 to the power 10 to the power t, 1, 2. So then this is going to be 2.4 10 to the power minus 2. The scale is kg, and this is become again cubic, m3, and this is going to be m3 again. I'm not going to write like this, I will explain, but 4 to the power 10 to the power t. So this is make into kilogram, so divide by 1000, and then this one want to turn into the meter, so then 100 by 100 by 100. So this is 1000, and this 2 is cancel out with this 2. So 4.5 multiplied by then 45 kg m minus 3. So I'm not going to do like that. If you can, otherwise we'll work with the simple mode. So this is going to be 4.5 into the power minus 2 gram, and this is going to be cm3. So basically 4.5 times 10 to the power divide by 1000, then it make kilogram, and this is 3 cm, so this is going to be divided by 1 cm times 1 cm times 1 cm. So this is 4.5 10 to the power minus 2 divided 1000 kg. So this is going to be 1 divided by 100, because centimeter, that's how we make it 200. 1 divided by 100, 1 divided by 100. So this is going to be 4.5 10 to the power minus 2 divided by 1000. This is 1 over 1 6. So I'll bring this 10 to the power minus 2 to down, 1 over 10 square. So then 10 square mean 100. So I'll write as 100. So over 1 over. So 4.5 over 1, 2, 3, 4, 5. 5 dots and 1 over 6 dots. So this is 4.5 over 1, 2, 3, 4, 5. And this is 1. So this is cancel out. And this is going to be 4.5 times 10, 45 kg. This is all become m. So m minus b. m. So m cube kg m cube. So by looking at this one, I can write 4.5 over 10 square or 100 GCM3. Or let me take a different approach. 4.5 10 to the power minus 2 and divide by 1000, and all divide by 1 over. If you are confident what you are doing, then will come like this, and this is going to be 4.5 10 to the power 5. This is 3 and minus 2 down 5, and this is 10 to the power 6. So this is going to be 4.5 10 to the power 5 over 10 to the power 6 over 1. So this is going to be 45 kg m cube. I can see numerator. Okay, assume I have a and b, a divided by b. So I want a divided by b. So I will divide a c and b t. So I divide a c and b t. Then final answer you can see a c b t. So if you divide by numerator by a value, so that value is in the denominator. If you divide by denominator by a value, that value in numerator. So AB as it is. So numerator division is gone to the denominator. Denominator division goes to the numerator. So having this knowledge, 4.5 10 minus 2, this is a denominator on. So I want to divide by 1000. And this is in a numerator, CM. And I want to divide by 100,000. So that is going up. 4.5 10 minus 2. This is 10 to the power 6 over 10 to the power 3. This is going to be 4.5 10 to the power 1, 45 kg minus 3. Question F 6.3, this is kg cm, so there's no worry about kg, only the problem is square centimeter. So this is 6.3 times 10 minus 3 divides 10 to the power 4 kg square meter. So this is going to be 6.3 times, this is minus 3 plus 4 kg m minus 2, 6.3 10.1 kg m minus 2, this is 63 kg m minus 2. Question number 2. A box is pushed along the rough ground. So there's a box and pushed along. So assume that it is a car, then it is going, so its generator is on forward thrust, which is B, forward thrust, and it has a weight that is normal C. And now we can see that we know that this box is touched with this table or rough ground. So two objects touch, as a result the normal reaction A is normal reaction. And given this ground is rough, then there is a friction. So this is a friction. Part B, a man swimming through the water. So a man swimming through the water, assume that it's like a car. The forward thrust generated by the motor. Likewise, is forward thrust generated by hand. So this is B is going to be forward thrust again. C is as usual weight, and buoyancy. A is and this one, water resistant. Water resistant usually depend on the density of the water or density of the liquid. Sometimes you may swim faster in sea, but sometimes not in river. because the density of the water is different. It is difficult to a fish to go in the mud uh, forward than the water. Part C is a duck. So it has a weight. So the duck on the surface, two objects touch together. Because of that, there is a normal reaction, and it was pulled. Then the tension is there, and this is a rough. Assuming this one is a rough, so this is B is going to be the friction. Part D, a man is sliding down along the hill. So weight is here, and this is a space, and with the touch another space, then the normal reaction, uh, normal reaction. So this value is going to be this E, and sliding down a hill on a sledge. So we have to assume this is a rough plane. Because of that, it creates a friction. That is C. If this is smooth, there is no friction.